In this video, we'll be covering C-style strings. In the original C language, strings were represented as an array of characters. Here, we're representing the word pi. We have the characters P, I, and E, all enclosed in single quotes, as well as the special \0 character, which is the null character. All C-style strings end with this null character. It acts as a sentinel of sorts that indicates the end of the string. In memory, C-style strings look something like this. Remember that they're just arrays, so each of the elements occupy contiguous memory locations. We can use this bracket syntax to access specific elements within the array. So for example, if our array or a C-style string is called word, and I do word and then in brackets 1, we get the character I. Using this initializer list is one way to define C-style strings, but you can also do so using string literals, as you can see on the bottom. So in this first option, we're defining the same C-style string for pi. On the right side, we just have the string pi, and in brackets, we specify the length as 4. What's key here is when you do specify the length, you must include space for the null character. So we know in reality pi only has 3 characters, but we must say the length is 4 because we need that extra slot for the null character in memory. Alternatively, you could just omit the length, and the compiler will handle everything for you. Regardless, when you do use string literals, that is, when the thing on the right-hand side is in double quotes, compiler will insert the null character for you, and you don't have to worry about explicitly including it like you do when you're using the initializer list. So we've established that a C-style string is just an array of characters. This means it undergoes array decay, just like any other array. So what does that look like? Well, consider this C-style string word1. If we try to use its value, like in this line down here, word1 double equals word2, we don't actually get the whole string pi. Rather, we get a pointer to its first element. Because this element is a character, the character p, this pointer is a char pointer. Now let's take a look at this example as a whole. So we have two C-style strings, word1 and word2, which both represent the word pi, and we have the expression word1 double equals word2. If we didn't know how array decay worked, we would assume that this expression evaluates true, right? Because word1 is pi, word2 is pi, these are the same string, and therefore they must be equal. But in reality, this expression is false, and this is why. As I mentioned before, when we try to get the value of word1, we don't actually get the string, we get a pointer to its first element. Similarly, when we say word2, we're getting a pointer to its first element, which is also the character p. Now, all pointers are addresses. So in reality, what we're comparing here are the addresses of the two characters p. So for word1, that's address 1000, and for word2, that's address 1004. Obviously, these addresses are not the same, so this expression evaluates to false. Now, I'm going to use this example to illustrate another concept. We know that if we try to use the value of a C-style string, we just get a char pointer. So what if we defined a char pointer as follows? As we discussed before, when we use the value of a C-style string, like we're doing on the right-hand side, it decays into a pointer to its first element. So in this case, ptr would just be pointing to the character p. Because it's a pointer and we're working with arrays, we can do pointer arithmetic. So say we do pointer plus plus. Just like with normal arrays, all this would do is advance the pointer to the next element in the array, or the next character in the string. So right now it's pointing to p. If we do pointer plus plus, the pointer would move to point to I. If we do pointer plus plus again, then the pointer would move to the next character, which is e. And finally, if we do pointer plus plus again, then the pointer would move to the null character, which means we've reached the end of the string. With the time we have left, let's take a look at this string length method, which takes in a C-style string and returns its length. So here, we're creating a C-style string called word. It represents the string pi, and we're passing it in as a parameter to our string length method. We know C-style strings decay into char pointers, so this parameter ptr is just going to point to the first element in our C-style string, as follows. Now we enter the body of the method, we create the local variable length, which is equal to 0. So now we check the while condition for the first time. Star pointer, we just dereference the pointer and see the character it's pointing at. In this case, that's p. P is not equal to the null character, so we enter the body of the while loop. We first increment length to 1, and then we do pointer plus plus, which as we discussed, moves the pointer to the next character in the string. So now we go back to the while condition. When we dereference ptr, we get the character I. Once again, this is not equal to the null character, so we do the same set of steps. We increment length, and then we advance ptr, so now it points to e. E is also not equal to the null character, so we increment length to 3, and advance ptr once again. And this time, when we dereference pointer, we get null character, which is equal to null character, so this condition is false, which means we exit out of the while loop and return length, which is currently 3. And that is correct. Pi has 3 characters,